Hello and welcome to our second last lesson for this particular unit. And what we're looking at today, we're looking at the topic of ratios. All right. And what's our goal today? I want you to be able to explain how to use a ratio, and then I want you to be able to use the ratio to solve real-world problems. So that's the ultimate goal, or what I want you to be able to do at the end of it. So for those that don't remember, don't know what the ratio was, let's talk about form and notation for a ratio. So ratios can be written in a couple of ways. The most common, when you think of a ratio is typically written in the form, and I'll use numbers here, 3 to 2. Okay. It can be written as a fraction. So I'll put the or 3 over 2. Okay. But this is the more common notation, is that 3 to 2. All right. And we're talking about one set of objects compared to another set of objects. So with a ratio, the nice thing with ratios, objects. The nice thing with ratios is that units don't matter. All right. So the units, they don't matter, and I'm going to put that up here as a star. So you can measure apples and oranges. You could measure kilometers versus time. It doesn't matter with ratios as long as there is some linear relationship, all right, or some relationship exists. So what I want to talk about then is the next step, or the connection with ratios, and that's a proportion. And a proportion is simply two ratios set equal to each other. So set equal to each other. All right, so an example would be 3 to 2 is equal to 6 to 4. Or I could do 5 to 3 equals 15 to 9. So this is a proportion. As soon as you see that equal sign in there, right, we are dealing with a proportion. So we're setting one ratio equal to the other. Now what you will notice is that it's very similar to equivalent fractions. The first ratio, if we multiply the 3 and 2 by 2, we get 6 and 4. So the second ratio is just twice as big. With this ratio, we find 5 to 3, we find it's 3 times bigger, and that's where we get our 15 and 9. So what we're going to see in the upcoming examples, we're going to see that there's missing values. So first thing we want to talk about is just writing the ratio for the following. So when you write the ratio for the following, so let's go with, I'll change color back here. So let's go with, if I do X's and O's. So what would the ratio be here? Well, the ratio would be 4 to 3, and that is X's to O's. Okay. If I did the plus symbols, we would have a 4 to 2 ratio of positive to negative. Okay. So all we're doing is we're setting up that ratio, the relationship between one item and another. All right. So there is our other ratio form, and you can write it in the other notation, or sorry, the other direction. You can also go 3 to 4. But it's very important to remember what each number is representing. And I always encourage at this stage that we put the little symbol above so that we can remember. All right. So if we want to solve proportions, and this is really the key here, the most important part of this process. So this is what it's going to look like. So if I have, and we'll go back to 3 to 2 equals blank blank to 14, what we're required to do, we need to find that missing value. So we need to know what is that value. So we know it's going to be some form of equivalent ratio. Still, the second term, the question becomes, what happened to that second term? So using your multiplication table, we know that 2 times 7 is 14. So whatever you do the first or the second term, you got to do the first. So times 7, 3 times 7, you're going to find that the missing value here is 21. So it's our missing value is 21. Okay, so that's why we went through, and I'll make a note of this. This is why in that first unit, so unit 1, we talked about, unit 1, we talked about equivalent fractions. All right, so it's a setup, a setup for this particular topic, because yeah, it's very, very similar, okay, these equivalent fractions. So second example, I'm going to do a couple here just to get the hang of it. So the second one, what happens if I have 5 to 9 equals 35 to blank? So it's the same thing. The difference is this time I know the first term of the second ratio. So that means it lines up. The first ones line up together. So the 5 and the 7 are partnered. So what did happen to that 5 to become a 35? Using your multiplication table, you had to multiply by 7. So now we find out, well, what is 9 times 7? And we get 63. All right, and a third example. What happens if I have first number, let's say the first one is 12 to 8, and now it's equal to 3 to blank. So this one's a little bit different because now the first terms, again, they're partnered up. But what happened to the 12 to get a 3? In order for the 12 to become a 3, it got smaller. And when you make things smaller, you divide. So 12 divided by 4 is 3. So that's what had to happen here. So we need to do our second term and divide it by 4. 8 divided by 4 would be 2. So it is possible you have to scale down, is what we call it. All right. Now, proportions can become a little bit larger. So for example, I could have a 3 to 5 to 2 ratio, and it's equal to blank to 15 to blank. So this is what we call a three-term ratio or a three-term proportion. So now if you want to solve this three-term proportion, you have to find the terms that match up, and it's our middle terms that match up, the 5 and the 15. So using your multiplication charts, we find that we had to multiply by 3. So that means that everything needs to be multiplied by 3. So 3 times 3, so the missing first term is a 9. And that 2 has to be multiplied by 3, which means that the missing term was a 6. All right, so we end up with a proportion that looks like that. Now, if we have, let's go with 25 to blank equals 5 to 2 to 4. the proportion's kind of been reversed. So we're still matching up those first terms. All right. So when we match up those first terms, we see that we're going to go in the opposite direction because the unknowns are in this direction. So I know everything on the right side. So I see that 5 times 5 gives me 25. So that means that the 2 is going to be multiplied by 5, which means the missing number here is 10. And the 4 has to also be multiplied by 5. 5 times 4 is 20. So there are missing values in the left proportion. So we're just playing with multiplying and dividing numbers to find those missing blanks. I'm going to leave it there for the moment, and in the final video I will do the examples, the real world examples that are tied to this.